Hey, hi. So, welcome back. So, we'll continue from where we left off. So, now we are going to look at the ingestion of the data from the TXT file and how it actually goes into the vector database, right? So, here is this function, and there's another one over here. This is to read from the TXT file, right? So, with open R, this thing f dot read path, we've already passed this on the top. Sorry. Uh, right? So that's over here, and that's a config thing. Okay, we also have put a fallback, right, in case it's not read out. So let's see where this function is getting called. So it's getting called over here. This is where we are passing that. We're calling this function. Okay, so it's passing on to this variable, which is string. Okay, read and file not found this thing. Return is this. Okay, so either we return this where everything is fine. If this is an error, we go to the fallback. Okay. Now, so that's our knowledge base. Once it's returned, it's passed to this variable, which is then goes over here where this function is called and passed on over here. Right. So we have that passed on over here. So this is recursive character text splitter. Okay, so we're just defining the structure, the configuration over here. Hey, we're going to do chunking, so we're going to break that entire bulk into pieces. We're going to into smaller chunks, right? So we're saying that chunk size is 380 and the overlap is 50. So essentially, when it goes to the next chunk, the size again will be 380, but it'll take from the last 50 of the earlier chunk. That's what we're saying over here, which is passed on to this variable. And when the splitting happens, right, the text, the knowledge base, which is passed here, okay, for chunks. So it go into that loop and goes into this document, which has a parameter called page. So chunk actually goes over there. So multiple such documents. So eventually when we call, we will see the doc length over here, right? How many such documents or pages have been created. All of this is in a pip install. So I'll just show you on the top. Mm, right? So this is all from LangChain. This is the text splitter and this is the document. And again from LangChain, we have our FAISS vector store, which is our vector database. These two we already saw. And this is for LangGraph, okay? State graph and end. So we will see this later. Okay, this is the other wrapper for our embedding model from LangChain. So we've got this. So this is a vector database, okay, which has this function to which we are passing the document and the vector database. So there are two components being passed over here. One is this and this is getting passed on over here. So the vector store. So when this function is called, eventually this vector database is getting returned. So, okay, so each document is turned into embedding. The FAISS stores them in fast vector index. This allows similarity search. This is your vector database, which is what I mentioned earlier. On this, we are actually putting a retriever, like a search on top of this using a function which gets saved over here. And the configuration of that is using MMR. And so let's try and understand this bit, how it actually works. So the search object is retriever, which is on top of the vector database, and MMR algorithm stands for maximum marginal relevance. So it looks at two things: the relevance and the diversity. How close is this? So you have all your data. Once a query comes in, we'll look at that. It's trying to get things which are relevant for this queries and which are also diverse. So if everything just becomes relevant, uh, it might be very similar. So it has to be relevant and yet diverse. And so you try and get that. Right? So the first eight fetch that actually happens, it uses a similarity search. FAISS uses similarity search called cosine or Euclidean distance and retrieves the top eight documents. This then goes into the MMR, which is your maximum marginal relevance. then the MMR calculates the marginal relevance for the remaining 7 documents. Okay. So then so then it selects the next document. It is not only relevant, but also different from the first one. Okay. So you get 2 documents that are retrieved, which are both relevant and diverse and not duplicate. So that becomes really important. Now, this is another function which is for the LLM. We will look at this, and then when all these function calls actually happen. So here the query goes in, which we saw earlier, and the context, which is what we will get from the earlier thing. So on this, you will actually see something called as retriever.invoke. Okay, so we will see that when we come to that, you will understand. So in this function, we have our prompt. Okay, so it's really important how the prompt is structured. It makes has a, so what I've seen from my experience is that the hyperparameter tuning for the LLM, the the prompt, in fact, everything, the chunking, the overlap, all these things are very significant in your output response. Obviously, the kind of model, right? So T5 large is just 780 parameters. So there are other models. If you have the kind of infrastructure to run that, right, essentially, so you can quantize those. So for example, if you take something which is a 7 billion parameter, if you quantize, it just reduces the size and you can still run it. So I did that on Google Colab for one of the Microsoft models, but unfortunately, even after doing that, I couldn't, there's limitation, right? So I couldn't do that. So I had to continue with this. Anyway, coming back to where we were. So you've got your prompt, you've got the context also that we are passing on over here, and the query. So now all of this goes into prompt, okay, which is over here. So essentially this is the prompt has your instruction, it has the context and the query, and we are saying finally the answer is to come over here. So using dot invoke, which is, this is the wrapper, okay, if you on our LLM, which we saw earlier. Okay, so we put a Hugging Face LangChain class on the pipeline, which is this, right? And that's what we are calling over here. And dot invoke, the prompt is passed. Okay, so you get it in result. If there are exceptions, then all of this return result. Now, this is where our fast API, we are initializing the web app. Passed over here. Okay, so this is essentially a decorator that we're going to use at the rate app.get. So get is just the, we're not really doing any processing, we're just getting the information. Dot post is where we want to do and some processing, and then get that information is when we use dot post. So this is the root node, which you will actually see. I'll take you through this. I will actually show this in the Swagger UI, which is from Fast API. Right, so this just returns certain things, standard, and you're passing is just script. You don't really need this, but if you're doing it the first time, it's nice, it's pretty handy. Here we are declaring a class of our own based on our Pydantic library, where we can have your custom classes. So this is one attribute variable string type. Couple of things. So okay, so after this is, so we're going to use a request library. Request does all your HTTP request, right? So which we have imported. Let me show you that. Where is it? Yes, this. Okay, so this will actually call on the @posts and all of that, right? So you will see that. Sorry, you need to scroll. Okay, so we have a class, so @post. Okay, so we are going to pass a URL. Okay, so there is something else that is going to get prefixed to this. So matches the URL from request.post. Okay, so this is a class that we have created. This will tell fast API and JSON is returned. Okay, so if you look at this, request.post will actually check for this @app.post, and it will match this. And this is what we are getting as an output. Okay, so this is actually a predefined keyword in the frame that the framework recognizes. It tells fast API expect this shape or type of response, that it is going to be dictionary, where the key is strings and the value is any type. So that's why we have this. So this is our output that we're going to get. This is only about the output part. This is the URL part. So this is our asynchronous function, which we mentioned about, so that when the request is placed, it doesn't stop, and uh, whatever else can be run in the background. So here there aren't too many things, but you will see that in a larger program how that actually helps. Okay, so this is the class that we created. So here is an instance of this particular class that we're creating. So, and hence, when we're calling this, it can access the attribute over here, which is this query. Okay, so in the try, so retriever. So this is the search object that we had created on our vector store, if you remember. Okay, dot invoke is when we're actually calling this. So this is the first attempt. The query is passed over here. Okay, this gets passed over here, which is a string, is what we are saying, and goes to docs. Okay, exception. Again, we make a second attempt. Basically, this does the same thing. It's just a second attempt. And context. So what actually happens over here, our vector store, if you remember, has two components. One is a document, which has the page content and the embedding model. So the retriever is a wrapper on that vector store. So it has the embedding model and the document. So it searches the FAISS based on the configurations and returns top k equal to 2. Okay, and this page.content is an um, parameter of document, and that's why we have this d.page. So if you look at this, docs, which is from here, getting passed down over here for d. So d.page. So that is joined. Okay, so you're just joining the string. So context. So we got the query, we've got the context. This is just to actually just like a check. Okay, this is another. So the function that we are calling, where we are passing this context and query, right? So the query is also getting embedded. Okay, so that is one thing that we have to understand. So the retriever is a wrapper on the vector store. It embeds the query using the same embedding model. Okay, so that is also happening. Based on that, it'll actually get the context. Okay, so this we already saw this, and we get the final answer over here, and the return to this. Okay, so to this we are getting the query, the final answer, index response. Just remember this, we're going to use this. Okay, so this is an entire dictionary with keys, key, and values. Okay, so this we are going to be referring. Okay, augment with LLM is the function that we saw earlier, is this. Okay, so the context and the query gets passed on over here. So the prompt has the instruction plus the context, and the query goes through the LLM. So I hope we're clear on that. This is again simple. This is for the zip code that we're using. We used this from, this is from OpenStreetMap data. Okay, yeah, OpenStreetMap rather. This is just a standard parameter that we have to pass. It just tells the service who is using it. Tells the service, who is using this data. We're passing this on to a variable. Okay, we're just creating a search. I just hard coded this. You can put any bank name and put a zip code. You can actually feed that, but I've just hard coded this. You can, yeah, so you can actually pass that. So to this we are passing, okay, so geolocator.geocode, okay, function to which we are passing this, and this, based on this name of the bank and the zip code, it'll actually give you the address. So if else except, okay, so the return is an address. So here is another class that we are creating, custom class based on this. There are two attributes, both string type. So this is used for our string type, used to create a custom class. There's something else that I wanted to mention on our base model that I missed earlier, I guess, which is there in my comments. Not sure if I mention that. Okay. So we saw all of this in terms of our uh, dict. Okay, any it can take integer. Sorry, whatever we say, and any means basically any data type. Okay, so and here we can have our customized, whatever data type. Base model also helps us to that, but the difference about base model is at a runtime it will check and do the conversion. So if this is so good, why aren't we using this? The primary reason is cost and CPU. So the base model runs validation logic every time an object is created. So for very large data, it slows down the whole thing. So there is cost attributed, right? So cost, CPU, memory. So that is why using type dict instead of base. So we have to see what can be used where. We need to understand a little bit of these things so we are using the right things. So basically that's what I wanted to share. When I looked at this, I just remembered that. Coming back to where we were. Right. So for the branch address, we are done with this part. Here's another class, agent state, which is creating based on this from typing library. Okay. So there are, so it calls the fast API query index endpoint and gets the answer. So there are two functions that we're using, which is going to be used by LangGraph. So tool node, let's just look at this. So it takes the query from the agent and it sends to the fast API endpoint, which is this, and it gets the response. So request.post. So we will look at that. Okay. So we are creating a class called agent state, which rather we created over here, in which there are two attributes. So this is an instance of this class. Okay, so here we are passing the URL. Okay, so let me just, okay, so we've actually, so if you look at this, we put this in our, we could actually put 0.0.0. That is a better option. So if you put host 0.0, all of this, so it's binding to all network interfaces. Any machine on the same network can access it. But if you use this, it's a private one. Okay, so we're actually using this as host. So we'll come to this. I just wanted to show you. Because we're using this, we're passing this over here. It's just hard coded. And the port, which is dynamic, using random.random, remember, seen it earlier. To that, we are appending this, which is going to go to our @post / query. Okay. So this is the URL. Okay. So this is an instance of this class, which has two attributes, which is your query and your RAG result. That's what. So we are, so this, it is calling one of those up to a limit of about 50 characters. Now we are using request.post, which is going to call @post this URL, and a JSON is passed our query, and we're putting timeout. So based on this, it will call this function, right? This decorator in this function. It will look for this, right? This is your response. So your output is over here. So what gets returned eventually is the query, the index, the final answer, and we're just putting this LLM model name. So that is passed on to this variable called response. So if status is true, this means everything is okay, right? So we just read dot get. Okay, so this is our, so dot get will give, so this is the key that we are passing for the dictionary. So if you remember, so this is what is got returned of this index underscore response, where is the, which is the final answer, is what we're calling over here in result. Okay, so response.json. Okay, so JSON is a Python. Yeah, I wanted to just share something. Okay, let me. Yeah, so well, this is what I want to share. I've just added this to the comments, right? So your .json is basically a HTTP response. So this is actually Python, right? When you do this, .loads makes it a JSON string, and .dumps makes it a Python object. So just remember that. So here we're using the get function, and we're getting the final result over here, and this is the default in case there's an error. Okay, else result, we're saying, so basically when the status code is not 200, if there's an error, it'll give you some other status code that goes into result. And the agent state, here you remember there are two attributes. So query is state query, and rag result is result, which is this result. So these are the two things in agent state, and state was the instance that we created. So this is coming in the return. So you will actually see when we are calling this tool node, LangGraph is going to call this. So we will see that. And the synthesis node, we're just doing a kind of a formatting. That's all. It's not being used to the depth at which it could probably be used. Right. So very simplified version. Again, same agent state. So you've got your query, and in the result, we're just doing some formatting over here, which will have the query. And when you're saying answer is via model, and this is the result, right? So this is the instance, and this is the attribute. So this instance can actually call this attribute. So Uvicorn is the server that we're using. So this is your fast API. This is the host name. I mentioned about this. The port is a random int, and we're just capturing log level. You can do info also. I prefer putting the error part of it, log level. After this, we have the Ngrok thing. This is the auth code for Ngrok, which you will get from Ngrok once you create the account, which is there in my JSON file from where I've actually pulled in the config path, right? And then so you're setting this, then you have the tunnel. Okay, so in this, we're just hitting .connect. We're putting the port over here, which is passed on over here. This you have to put, others you're getting errors. So initially I didn't need this, but later on I was getting into errors with the Ngrok tunnel. So when you do tunnel.public URL, you will get the URL. Okay, this is going to give us our fast API. We're just capturing this is our fast API endpoint, and we put docs. This is where we will actually do our test, endpoint testing. So there are two endpoints at the rate /query index and get branch info, which is what we saw earlier. This is one, and at the rate post, yeah, this is the second one. So this is done. Now this is the development testing environment, right? So we're using the if name equal to main threading. This is the library that we imported .thread. So we're creating a thread. This run server. This is our Uvicorn that we're running function, right? This, which will instantiate the fast API. Daemon equal to true basically means when the main program finishes, all running daemon threads are immediately and abruptly terminated. That's why we're setting that equal to true. We're just putting a sleep of 15 so that, whatever has to be instantiated happens. And now we're calling the other function Ngrok in this name equal to main. Where did that go? Yes, this, okay. Now is our, okay, this is from LangGraph, okay. So we're using this, in which we are passing state agent, the class that we created, okay, which had query and which also had rag result. To this, we are adding a node, okay, that's the first node. And this node, tool node, which is a function, we are giving this name, okay, this particular function, agent. So this class is what we passed, okay, this class was created over here. Is what we passed here is again given to LangGraph. Okay, so this is the first node, this is the second node, which is the other node. Okay, and so then we are saying this is the entry point. Okay, so that is how. So when you have graph.invoke, which will come to, it will actually go to the entry point, and then it tells this is the path. So it's not very complicated, pretty linear in that sense. And then we are saying this is the endpoint, right? So it'll go through start over here, and we'll say this is the path. So it'll go here, and then after that, okay. So once we have all of this, we're doing a compilation. We are setting in 3 test queries, okay, right, based on our database, and we are running a loop, graph.invoke, the same graph.invoke. We are passing this query, okay, so test queries for Q in this, which will pick up the first one. Recursion limit is equal to this timeout. So we're putting a timeout of 300. Some of these things based on the LLM and all, it may take time. So recursion limit is set the maximum depth of the nested node calls in LangGraph. So some of these nodes can call, each other. Ours is pretty linear, so we're not really using this, but it's just given over there. So you have your final state RAG result. This is the final thing. After this, you have one more URL. So we're not using LangGraph, we're just directly using requests over here. So what happens is invoke. Okay, so this will call, what will it call? It will call this one, the entry point. So which means it will call to make a call to this function, tool node. Okay, so it will go to this post, @post is going to call, where was that? This one. Okay, retriever.invoke, we know what is going to happen. This is going to get embedded. The query is going to get embedded, right? So @post does all of this. So we get the context and all of that. Okay, another function is called. This is for the LLM. So all the things that we saw, this is how the calling is happening. Okay, so our prompt, everything happens over here, right? So this is a function that is getting called, prompt with the instruction, context query. The LLM is invoked and we get our output. Right, so that is how that works. Just wanted to show you all the flow. Okay, so that comes into the final result. Sorry, final state rather. Okay, so RAG's result. And this is the other one that we are doing. Okay, so this is what we passed to Uvicorn and the port, and we say as branch, and we're actually passing this directly over here. We're using @app.get. Okay, so that's why this question mark and zip code is equal to this. Okay, and then we're using a get branch address. Why branch address? Because that is what we have used earlier. Right, so this is what this is getting returned. It's a dictionary. So your key and your value. So it will look for the zip code. Okay, so this variable is of type string to which we have hard coded a value and given. So yeah, so while true, so when the reason we and then we're doing try and except while true, so it'll look for this condition in the if name equal to main, and we'll keep this running on. Okay, because we have to use Gradio. Okay, so it'll be on so that the entire processor is not used, so we are using the sleep mode. Then except this is for key interruption. I can just hit the pause and it'll stop. Okay, so if tunnel object, then it'll kill Ngrok. So I have already run this. Okay, if I run this now in the record mode, it's going to take some time. So I've already run this. So this is what you will see in your output, everything. So I mentioned about this, right? So, okay, there are these 8 indexes, those documents that we were talking about. This is the link that was created, and this is the Swagger where you can test the endpoints. Let's look at what this looks like. So if you remember this, okay, you remember in the return, this is what we had seen. So this is what we are getting. This is our root node. which is @get this. Okay. And the other one, so this is the other link. Okay, /docs, which is what we appended to this. Okay, it was in the main function. It was in the Ngrok. Sorry, my bad. Yeah, so this is what we got. So this is what got printed down at the bottom. Okay, so when you click on this is what you get. Okay, so and you will get something called try it out. So that's what I did. Also here there was something called try it out query. This is where we're passing a query. So I hit that. So I got this. So in the query, I actually pasted my query and I hit execute. Okay. When I hit execute, I get my response over here. So this is the output that we're getting. So what was the query? So this is what we are printing. Remember the return, those three things that we are returning. Yeah, so this is what we're returning, remember. Same thing. Okay, and then you also have for the address. So yeah, based on the pin code, uh, hit try out. Okay, that will be there initially. When you hit that, you will get this box. You hit execute, you'll get your response over here. Based on this, it will say, hey, branch address is this. Okay, so I put that pin code and I mapped it to this bank, and hence I get this address. So this is how you can actually test your endpoints. This is the Swagger UI, which is part of FAST API. You can test your endpoints. So once you run in Collab, there is no problem. But once you go to Docker, Collab has 12 GB plus RAM. Plus, if you use your T4 GPU, so in runtime, it allows you to change. So you can actually use this. So because we are install accelerator, which is part of accelerate, which is part of your transformer, the LLMs and all get loaded through that. So we've done this. We've also imported, right? So that is what actually happens by default, and you can actually also specify. So I'm not going into that right now. I hope you're good so far, right? So we are seeing all this output. So the query, we just said, print a small portion of that. And so this is what we got in our response. Query answer, okay, via this particular model, and this is our response. So it is giving us all the responses. So that's for the first query, second query, third query, and then also the branch address. This we are seeing because I used the Uvicorn, the Gradio UI and hit, and I've then shut down. So that's why you're actually seeing this. I'll come to this part. Cool. So this was pretty interesting. I guess slightly lengthy video. I probably have maybe another part or two in continuation to this. I'll see you then.